everyone, welcome to my YouTube channel. Let's continue previous tutorial about how to create the object instance for our plane, and I'm gonna be distributing our cube over there onto these vertices of the plane as shown in our example. So we should apply the subdivision surface modifier on our plane. Just set it not to Catmull Clark, just simple. Then set level to 3 and also render to 3. I'm gonna be adding point instance, and you should slot it after the group input as shown here. Then go to select cube in order to set it like this. Just I'm gonna be scaling, hit the tab key on the keyboard, then L to select this cube, just hit S to just scale it. Just drag the mouse cursor as shown here. Tap to object mode. It's gonna be creating this bunch and instance object for our cube onto the vertices of the plane. Let's move on to show you how to use an empty object to calculate proximity data. Let's take a moment to discuss the next few steps. The idea is to calculate the proximity between an empty object in our scene and each of cube instances. We can then use this proximity data to modify each cube's rotation or any other type of attribute. For this, we will also be using the vertex weight proximity modifier to calculate proximity and then save it into a vertex group that we will create. You will discover that there are many different ways to do interesting things using geometry nodes, so never feel that you need to do it certain way. If you can calculate the data that you need, you are on the right track. Experiment and practice. So let's show you how to calculate proximity. In this section we'll be creating an empty object and using it to calculate proximity data. The first step is let's start by creating an empty object in our scene. Press Shift A and select empty sphere. Shift A, then go over here to select empty. You just search for sphere as shown here. It's added to the scene. You can choose any shape you want. Scale the empty object by pressing S and moving the mouse until it's a comfortable size. So just scale it like this. Then grab it. Just move it on the x-axis to this place, to this location. Move the empty object to edge of the cube instances as shown here. With the empty object selected, press G, then X and drag the mouse. Next, let's add the vertex weight proximity modifier to our plane object. Click on one of the cube instances to select our hidden plane, like this. In the modifier panel, click on Add Modifier. So just click on Add Modifier, go over there for Modify Category, search for Vertex Weight Proximity. From the list under the Modify column, click on it. Make sure this modifier is between our subdivision modifier and the geometry nodes. So just hold it, then make sure that it's between the subdivision surface modifier. Click on it to just to move it like this, and you can hold and click on the left mouse button, hold, then you can move it down in order to change its position. If we place it below the geometry nodes modifier, we won't be able to use the data within the geometry node editor window. You can drag the modifier using the handle on the right hand side as shown in our example. in this button over there, you can drag modifier using the handle on the right hand side to rearrange the modifier stack. And it should be look like this, and you have the panel of the vertex weight proximity. So let's move on. Next, we need to create a new vertex group on the plane so that we can configure this modifier. Before we do this, let's disable the viewport display of the geometry nodes. Just like this, disable it. It's gonna be going back to set the previous settings. Click on. So the reason for this is that we need to see our plane to create a vertex group. Click on the viewport display icon on geometry nodes modifier to disable it, as shown in our example is disabled for geometry nodes. Then we'll be able to see the plane object again in the viewport. So select the plane in the 3D viewport window and click on the object data properties. The plane should be selected. Go over object data properties. I think it's over here. Object data properties. Object data properties is over there. It's gonna be showing this panel. Click on the plus icon and the vertex groups as shown here. Click on plus icon. So the next step, rename the vertex group by double clicking on its name. Call it plane, for example. Like this is gonna be renaming it plane, hit enter as shown in our example. The next step, mouse over 3D viewport window and press tab to enter edit mode. It's over there. Then go over here. Then set it to edit mode. Then you go to ensure you are in vertex select mode by pressing the one shortcut key. Or if it doesn't work, you can go over there and click on this button in order to set it to vertex select mode. Now you should press A to select all the vertices of the plane and then click on the assign button in the vertex groups window. Go over here, then click on the assign button as shown here. So hover over 3D viewport window and press the tab to exit edit mode. Like this, in order to exit edit mode. Now let's configure our vertex weight proximity modifier with the plane object still selected as shown here. Click on the modifier tab to see the modifiers. Click on the modifier tab to see the modifiers as shown here. You will see the empty boxes in the vertex weight proximity. We have two empty boxes in this modifier. Click on the box next to vertex group like this. And select a plane from the list. Should select a plane from the list as shown here. Then click on the box next to vertex group and select plane from the list. This is the vertex group we have just created. Click on the box next to target object. It's shown here like this. It's gonna be showing this drop down menu. Change proximity mode from object to geometry. Should select empty like this. Then the proximity mode from object to geometry. Click on it, then change it to geometry as shown in our settings. This will ensure that we are using the plane geometry and not just the entire object. The next step is you should hover your mouse over 3D viewport editor and click on the drop down list in the upper left corner. Select weight paint. Go over there and select weight paint. It's gonna be changing to this color of the plane. Now you will be able to see the weight and how the position of the empty object affects it. So, what is the meaning of these colors in our scene? Remember that red is displaying value of 1 all over this plane, and the blue is displaying value of 0. So we just need to grab it or just move it just closer to this plane to show some colors in order to show you something very interesting. Object mode, then just we want to grab it along the x-axis just a tiny bit. It's gonna be touching the plane. The empty gonna be touching plane. Go over there, select the plane, then go back to select the weight paint mode as shown here. And as shown in our example, as I mentioned, the blue is gonna be displaying value 0 and the red is gonna be displaying the value 1. Let's invert this by having red closest to our empty object and blue farthest away. The next step in the vertex weight proximity modifier, go over this panel, change the lowest value to 10 meter. Lowest value is 10 meter as shown here, and go to highest value, change it to like this, hit enter. Then this should invert our colors, and as you can see in our scene. Looking at the 3D viewport window, we see that the weight paint colors have been inverted. The area closest to the empty object is showing a red color, which has a weight paint value of 1, while the area farthest, let's drag it a tiny bit to show you, while the area farthest away from the empty object is showing blue, as in our example, which has a weight paint value of 0, as shown in the following tutorial. In the 3D viewport editor, let's change back to object mode. Click on this button and clicking on the drop down menu in the upper left corner again and selecting object mode as shown here. So enable the geometry nodes modifier in the viewport. So just click on this to hide it, then click on the viewport display icon next to the modifier again, as shown here. Click on one of the cube instances to select the plane. You should select one of these cubes over there and click on use nodes over here. It's gonna be showing this nodes group input connected to group output. I'm gonna be using the proximity data to modify the attributes. So let me show you how to do it. Let's add our nodes. Let's begin by adding our next node. Press Shift A and select attribute, Shift A and attribute, then search for attribute combine XYZ. Click on it, then drag it over there to connect it in between group output and group input, and slot it right after the group input as shown here. The attribute combine XYZ node combines 3 values into one vector attribute as the result. For the 3 values, we can either use a float value or another attribute. The idea is to make use of the vertex group proximity data, that is vertex group called plane. We are going to take this proximity value and use it to drive the z-axis rotation of our instance objects. We are only going to rotate our cubes in the z-axis and not the x-axis and the y-axis. Let's explore how we can do this. For the x value, leave it as float, as shown here. It's float. We'll be using a value of 0 because we are not changing this x rotation value. For the y value, leave it as float as well. We will also be using a value of 0 because we don't want to rotate in we don't want to rotate in the y-axis, change the z value to attribute. Go over here, then change it to attribute. Here we will make use of a proximity data in the empty box. Next to z, type in the name of the vertex group that we have created. It's over there. Should retype it and then type in the name of the vertex group that we have created, plain, and press enter. Additionally, you can select it from the list. These attributes are case sensitive, so make sure you are using the correct case. Just retype it like this. Now we need to save these three results, 0 and 0 plain, 0 and 0 plain, into an attribute node. We can either create a new attribute or overwrite an existing attribute. Let's overwrite the rotation attribute of our instance objects with these new values. Enter rotation into the empty box next to result. We need to enter rotation. Then press enter. You should do all the settings that I have talked about earlier. You will notice that your scene in 3D viewport window has been updated. The cube instance is closest to the empty object. Round in the 3D viewport window, see how it affects cubes. If you want to move the empty object along the z-axis only, click on the empty object. In the viewport selected, press G and press Shift Z. This will be enabled to move the empty object along the x-axis only. Select the empty object, grab, then Shift Z.